11.6 is all on inverse variations. Inverse variations are graphs of rational functions. So there's equation forms of inverse variations, and there's two formulas for these. One is xy equals k, and the other is y equals k over x. So when I give you a question that talks about varying inversely, the key words are varies inversely, and this one says, suppose y varies inversely with x and y equals 8 when x equals 3. What is an equation for the inverse variation? So what you're going to do is plug in for x and y, and you're going to find k. So if I plug in for x and y, I get, since x is 3 and y is 8, you get 3 times 8 equals k. So that means that k is 24. Then they want to know an equation for an inverse variation, so we're going to say that the equation is going to be xy equals 24, or also we could also use this one, y equals 24 over x. So your first step is to find k, and your second step is to plug k into the formula. So you're plugging into the formula twice. First you're plugging in x and y and finding k, and then you're taking the k and you're plugging it into the formula and leaving x and y in there. So we'll do another question. We've got x and y again, so we're going to plug it into the formula, and we're going to do 6 times 9 equals k, which means k equals 54. Now we're going to take the k and plug it into the formula, so xy equals 54. Or also we could say y equals 54 over x. Okay, easy breezy. All right, example 2 gets complicated. There's a 160-pound person trying to balance an elephant, and it's possible, but you have to know how far away from the fulcrum you have to be to balance that elephant. So what you need to know is that to balance, the constant of variation has to be the same, which means the k has to equal. Well, the question tells you that the weight varies inversely with the distance. So if I find the k for both of them and set them equal, I will be able to know how far I have to be from the fulcrum to balance that elephant. So you don't really have to set the k's equal, you just have to set xy equal. So I'm going to take x times y, and it really doesn't matter which one you call x and which one you call y. So 1,000 times 7, and I'm going to set it equal to my weight times the distance from the fulcrum. And then I'm going to find out what x has to be. So I get 7,000 equals 160x, and if I divide both sides by 160, I get 43.75. So that means that for the 160-pound person, they have to sit 43.75 feet from the fulcrum. So it is possible. I don't know if you'd want to do it. I don't know what kind of board's going to be strong enough to do that, but it is possible. Okay, so now I've got a 120-pound person. No, I've got a 120-pound weight 5 feet from the fulcrum. How far from the fulcrum should an 80-pound weight be placed to balance the lever? So I need to know x here. So this one's 120, and this one is 80. So we're going to multiply these and set them equal. So 120 times 5 is going to be 600. And then 80 times x. Now divide both sides by 80. You get 7.5. All right, now we're going to graph an inverse variation. You can graph anything under the sun if you make a table for it. So let's make a table. XY table. Choose some x's and find your y's. So you're always going to choose -2, -1, 0, 1, and 2. Not always, but you know, they're good numbers to pick. So if you plug in -2, you get 8 divided by -2, which is -4. If you plug in -1, you get 8 divided by -1, which is -8. If you plug in 0, you get 8 divided by 0, which is undefined. So yes, you do need to write that in there. That's important. If you plug in 1, you get 8 divided by 1, which is 8. And if you plug in 2, you get 8 divided by 2, which is 4. And I'm just plugging into this. So now you have some points. I want you to graph those points on your graph. And you probably do need some graph paper for this. So we're going to go -2, -4 is going to go left 2, down 4. My graph's not big enough for this, so let's count by 2s. -2, -4, we're going to go left 1, down 2 for counting by 2s. -1, -8, we're going to go left a half and down 4. 0 and undefined means there is not a single point on the 0 y-axis because it's undefined. 1, 8, we're going to go right 1 and up 4, right 1/2 and up 4 because we're counting by 2s. And then 2, 4, we're going to go right 1 and up 2. Okay, so that looks like it's going to be hard to graph, but you kind of need to know what the graphs are going to look like. So I can't graph from that. What am I going to do if I can't graph from that? You're going to pick more numbers. Always pick more numbers if you can't figure it out from what you've got. So instead of, I have to divide 8. So we're going to pick, easy numbers to divide into 8. So now let's pick 4 and -4. 8 divided by 4 is 2, and 8 divided by -4 is -2. So now if we graph the point 4, 2, we're going to go right 2, up 1. And if we graph the point -4, -2, we're going to go left 2, down 1. And now it's easier to see. What you've got is the graph of an inverse variation. And to graph it, it's going to be a curve just like that. That's what the graph of an inverse variation looks like. And when it's undefined at 0, it means it's almost kind of afraid of 0. It never actually gets to 0. It's impossible to get to 0. So the graph will never touch this y-axis, ever. And it's also going to approach the x-axis, but never touch it either. Okay? All right, so we want to graph another one. We won't do this B right here. We want to graph another one. What's the graph of y equals -8 over x? So I'm just going to write that down here. You're going to make an XY table. You're going to choose some x's. And you got to divide into 8. So you're going to pick easy numbers for that. So how about -4, -2, -1, 0, 1, 2, and 4. That's a lot of numbers. I realize that. But you need a lot of numbers to graph these. So if you plug in -4, you get +2. If you plug in -2, you get +4. And all I'm doing here is dividing this number by this number, and then this number by this number. So -8 divided by -1 is +8. -8 divided by 0 is undefined. -8 divided by 1 is -8. -8 divided by 2 is -4. -8 divided by 4 is -2. And now graph those. So, again, my graph is not big enough, so I'm going to have to count by 2s. So, I'm going to go graph the point -4, -2. I'm going to go left 1, 2, 3, 4, up 2. So right there. Then I'm going to go left 2, up 4. 1, 2, 1, 2, 3, 4. There we go. Then -1 and +8, so we're going to go to left 1, up 1, 2, 3, 4, 5, 6, 7, 8, right there. You can see a curve, which is good. And then for the other side, we're going to go right a half and down 8. Then we're going to go right 1, because I have to go 2, and I'm counting by 2, so 2. And then we're going to go down 4. And then we're going to go right 4 and down 2. And I see another curve, hopefully the opposite of my other curve, and there I've graphed it. So an inverse variation looks like that every time. It's 2 curves. And again, they didn't touch the x-axis and they won't touch the y-axis. All right, here's the difference between direct variation and inverse variation. Direct variation goes directly through the origin, and inverse variation is almost afraid of the origin. It gets close and it turns around. Same on the other side. Okay? You'll see the words varies directly for direct variation and varies inversely for inverse variation. All right, so how do you tell the difference when you look at a table? For either one, if you think it's inverse variation or you think it's direct variation, there's 2 tests. The direct variation test is where you take the y and divide it by the x. And you're going to take each ratio of y to x and see if they're the same. And if they are the same, then that is a direct variation. And for this one, they do seem to be the same. So because they are the same, that's a direct variation. Okay, and then B, I'll show you the inverse variation test. What you do is you multiply. And if the product of x and y is the same, then it's an inverse variation. Okay, so for direct variation, you're going to find the ratio, or you're going to divide. And for inverse variation, it's if the products are the same. Okay, so I want you to try these 2. Find the product of x and y. If it's the same, it's inverse variation. If it's not the same, try the ratio of x to y. And if it's the same, it's direct variation. And I'll tell you what they are in just a second. All right, so the left one is a direct variation and the right one is an inverse variation. And then they want you to tell the equation to model the data. So the direct variation, you had to find the ratio, and that was going to be 12 divided by 4, which is -3. So that's your k. So it's going to be y equals kx, which is y equals -3x. That's your equation. Your inverse variation equation is xy equals k. So my ratio was -48. So my formula is xy equals -48. All right, now let's look at an example of looking at an example and finding out whether it's inverse or direct variation. The cost of a $120 boat rental is split among several friends. When you look at that and you actually put yourself in those people's shoes, you're going to take the number of friends times the money each friend pays, and that's going to be $120. It doesn't matter if 10 friends are paying or if 12 friends are paying, the total is always going to be $120. So since the product is always going to be $120, the product is the same, so this is an inverse variation. And the reasoning is because your product is constant. All right, B, you download several movies for $14.99 each. Your total for your movies is going to change. When you multiply your number of movies, you're always going to multiply it by $14.99, but your total is always going to be different depending on how many movies you make. So that is not an inverse variation. Actually, if you take your total cost and you divide it by the number of movies you purchase, what's going to remain the same is the $14.99 that you paid. So the ratio here, it stays the same, which makes it a direct variation. And your reasoning is because the ratio stays the same. And here it was because the product stayed the same. So example 5, I want you to try those two. Pause the video and I'll give you the answers. All right, A is a direct variation because the ratio of the total cost to the number of sweaters bought is constant. And then B is an inverse variation because the product of your speed and time spent walking is a constant. You're always walking the same distance every day. Okay, if you need me, you know how to get in touch with me. Otherwise, make sure you know this video because you got a quiz coming.